Hello everyone, and thank you for using Danomics. In this video, I'm going to demonstrate how we can use some of Danomics' spatial interpretation tools to improve our interpretation. Let's get started. So I'm going to go to our TOC interpretation module. Now, we had performed our TOC interpretation already, and when we look at the results that we have here, we're using the modified Passy method, and we've calculated some TOC for both our Niobrara and our Maori formations. One of the critical inputs to this calculation is maturity. So this could be a vitrinite reflectance or a Tmax measurement. In Danomics, we take your vitrinite reflectance and we convert that to the, quote, level of maturity that Passy used in his methodologies. But this is a critical input. And of course, as you know, maturity is something that varies spatially across our area. It's a product of heat flow, burial depth, etc. So this is something that we'll often want to vary spatially. Danomics has built-in tools for doing this. So let's take a look at how that works. So I'm going to expand out my files area, and I'm going to bring in some data that we've measured. This will be data from the Niobrara and the Maori formations of vitrinite reflectance. So to do this, I'm going to right-click, I'm going to say Upload Points, and I'm going to call this VRE data as the name that I'm giving it. I'm going to choose that file. And here is the data that I'm bringing in. So I have an API, a lat, a long, a zone name, and my VRE values. So I'm going to hit OK here, and this data will upload. It'll then be processed, and then it'll be available for us to use. With points data, here I'm bringing in around 100 points. As you can see, it's essentially instantaneous that data is available to us. Okay, so now here we have it. And I can click on the database and I can preview this. Now what I need to do is I want to make a grid of this data. So how can I do that in Danomics? Well, I can use some of our gridding tools, and in this case I'm going to use a gridding tool called the flow. So I'm going to right click, I'm going to say File, New Flow, and I'm going to call this VREGrid.flow. Okay. So a flow is just a way to process data and to convert data from one type to another. So in this case, I'm going from points to a grid. So I need to add some tools to this flow. So first, I'm going to say New, and I'm going to say Points. And so we're going to say Points Input. I'm going to say Add, and I'm going to select the data. So I'm going to select my VRE data that I just loaded. Then I need to turn this into a grid, so I'm going to say points to grid, add, and then I'm going to say, finally, grid output. Okay, and you'll notice here it's giving me a little error message. So if I click on points to grid, it says column value not found, and that's because I need to provide some information to it. So first of all, I'm going to say lat is lat, long is long, and our value here is VRE. Now, I have multiple zones here in my project, so I want to group the data by zone. So I'm going to say custom, and I'm going to say group by zone. So this means that when it's Maori, it'll come as Maori, and when it's Niobrara, it'll be mapped as Niobrara. Okay. For the projection source, we've not set this yet. We're just going to use the default project projection. And then for one last thing to set here is how we want this to be gridded. I want to use kriging specifically to perform this grid. And then for my output, I'm going to say VRE grid here. I'm going to hit run. This will pop open the jobs menu, and it'll go through the phases of initializing, running, and then finished. Generally, this will be a fairly quick process that will only take a few seconds. Okay, we can see now that our grid has ran. If we click on the job summary here, it tells us how many points were used on each one, and it gives us the status that it succeeded. We also notice that over here, we now have our VRE grid, and if I click on this, we can see that we have a grid here for the Niobrara, and that we also have a grid for the Maori. So that's just a quick grid preview. Now let's say I want to use those grids to populate the effective the equivalent vitrinite maturity here for the Niobrara. What do? When I hover over this parameter box, I see this little gear icon. If I click on that, I can select interpolated table, and then I can select my VRE grid, and then I tell it that I want to use it for the Niobrara formation, and I click OK. When I do this, I can see that the Niobrara now has a value of 1.118. And let's say I come over here and I click on another well, I can see that the maturity over here is only 0.78. And if I click down here, I can see that I have a value of 1.083. So now we can see that it is spatially varying this, and if I want to see the map of that property, I can come down here and I can select to show that Niobrara grid, and it'll show me what the grid of maturity looks like. Okay, let's say the other zone that I want to calculate TOC for is the Maori formation. So once again, how do I do that? I hover over the parameter box, I click on the gear icon, I select interpolated table, I choose the grid that I want to use, choose the formation that I want to use it for, and I hit OK. And now we can see that the Maori, slightly higher maturity in this area, which is what we would expect because it's the deeper of the two formations. All right, so now we have varied these properties spatially using data that we measured from core in this case across a number of wells in our area. What are some other properties that you may want to use this method for? So, for example, in your water saturation, your RW as measured at the surface, your formation water resistivity, often changes across your area. So maybe you would like to vary that spatially. Well, you could bring in this data and perform this operation and use it here. Another area where we see this quite often used is in the volumetrics interpretation. So whether or not you're using the Vasquez-Beggs and Hall-Yarborough correlations for gas and oil gravity, you could bring those properties in. You could also bring in things like your liquids yield or your GOR to calculate, to be varied spatially across the area. And then finally, a place where we see people use properties is when we have some statistical properties that we want to use. For example, if we were to look at our mineral inversion uses things like the sonic value of our clay. Well, this varies with burial and compaction. So perhaps when you're doing this interpretation, you would like to come in and have this property vary spatially. Well, you can do that. You can use Danomics to make a grid of, let's say, your of the average sonic value in high clay zones, and then you can bring that in using this interpolated table option within your mineral inversion. So there's all sorts of places where you can use interpolated properties to drive your petrophysical interpretation. I may not recommend doing this on your first pass, but as you start to build up more and more sophisticated interpretations in Danomics, I think this will be a powerful tool for you to use. All right, I hope this was useful to you, and if you have any questions about how to use spatially varying properties in your interpretation, please reach out to us at support@danomics.com. Thank you.